Hey guys, welcome to my channel. When you think of infrastructure in the United States, the first things that probably come to mind are the iconic orange-red cables of the Golden Gate Bridge, or the endless stream of cars on the interstate highways. These are, without a doubt, symbols of American pride. After all, the Golden Gate Bridge was completed in 1937, and the Hoover Dam stunned the world back in the 1930s. But today, let's shift our focus halfway across the globe to China. There, a groundbreaking infrastructure revolution is unfolding, one that is redefining the scale, the speed, and the technological limits of what we once called engineering marvels. This is the story of China's infrastructure, a story of breathtaking ambition and record-breaking projects, of a nation reshaping its landscape at lightning speed and rewriting the global playbook for what infrastructure can achieve. Can you believe this? While America is still stuck in endless debates just to renovate a single bridge, China has already built the tallest bridge on Earth, suspended between cliffs as high as a 200-story skyscraper. While American high-speed rail proposals are still stuck in Congress, China's bullet trains are racing at 421 kilometers per hour across a staggering 40,000 kilometers of high-speed rail, more than the rest of the entire world combined. This isn't a sci-fi movie. This is real. This is China, redefining what's possible in engineering, one mega project at a time. To be honest, when it comes to infrastructure, the gap between China and the US might be far bigger than you think. Take high-speed rail, for example. America's first high-speed rail project, the California High-Speed Rail, was approved back in 2008, and the result? 16 years later, it's still not finished. The original budget of $33 billion has ballooned to over $128 billion. So we're here to talk about the California High-Speed Rail project. The voters of California voted in Proposition 1A that they would have a high-speed rail from LA to San Francisco. It was going to be done by 2020, and it was going to cost $33 billion. And people were excited. They were thrilled. Take people off the road, out of the air, put them on rail, move them quickly. It was an exciting time. Exciting promises for an exciting project. Where are we today? Well, today we are severely, no pun intended, off track. And that project, thus far, is going to cost the California taxpayer and the federal taxpayer, at best estimates, $33 to $35 billion. At best, that portion of the project is not going to be completed until 2033, 2035, way after this whole project was to be completed. With the $15.7 billion already invested in a project that has given you bridges here to my left and to my right. Bridges to nowhere, right? But this project, if completed 400 miles from LA to San Francisco, at best, it'll cost $106 billion. Now most people will say, that is a rosy estimate. There's no way it's going to be completed for $106 billion, which, just to do some simple math, that's 3 times. Fuck. Meanwhile, in China, since the Beijing-Tianjin line opened in 2008, China has built over 40,000 kilometers of high-speed rail. It's enough to circle the Earth at the equator, and then some. However, China's average construction cost is only 1/5 of California's high-speed rail project. It's like China is riding a rocket while the US is still on a bicycle. From the frozen highlands of the north to sun-drenched tropical shores, China's vast high-speed rail network keeps racing forward, to day in and day out. Now let's talk bridges. Sure, the Golden Gate Bridge is iconic, but today, 42% of US bridges are past their intended service life, causing an estimated $110 billion in economic losses every year, due to aging and deterioration. In contrast, China is home to 8 of the 10 longest sea-crossing bridges in the world, and the construction efficiency, absolutely staggering. In the US, building a standard bridge can take 7 to 10 years. But in China, advanced pivot technology has made it possible for a 16 300-ton bridge to rotate 180 degrees and connect in just 90 minutes. In 2019, the Pingjiang Bridge in Hebei completed its pivot in only 85 minutes, a new world record. One American viewer even joked, "Do people in China have more hours in a day than we do?" So where does this massive gap come from? It boils down to fundamentally different approaches to infrastructure. But in China, centralized planning and powerful execution enable the country to rally national resources for major challenges. Just look at the Hong Kong-Zhuhai-Macau Bridge. More than 1,400 companies and tens of thousands of engineers work together on a single goal. That kind of nationwide coordination is nearly impossible to replicate in the US. And yet, in the face of what many consider a modern engineering miracle, some voices online from the US have raised doubts. With China's current level of industrial development, can this bridge really hold up? I bet it'll need a full overhaul in just a few years. It can't compare to Brooklyn Bridge, USA. This is just a showpiece, no real use, just trying to flex on the world stage. A waste of money, purely symbolic, with no real benefit to the region. But these dismissive comments reveal less about the bridge and far more about their own comprehension limits. They conveniently ignore the 1,000 plus patented technologies developed during the construction. They overlook the 6.7-kilometer undersea immersed tunnel, built with a precision tolerance of less than 5 millimeters. And they're unaware of the bridge's advanced design, with multi-layered anti-corrosion systems, seismic resilience, and the ability to withstand Category 16 typhoons, magnitude 8 earthquakes, and even a 300,000-ton ship collision. When Chinese engineers declared a 120-year design lifespan, it wasn't a marketing slogan. It was backed by hard data, rigorous testing, and world-class engineering. These unfounded criticisms aren't about the bridge. They're about the growing unease of watching China's engineering capabilities rise, with a speed and confidence the world didn't expect. Oh God, please. No. Imagine this. The roaring waves of the Lingdingyang Strait, 33 massive immersed tunnel segments, each as tall as an 8-story building, and weighing 80,000 tons, had to be aligned and joined together with Lego-like precision. The margin of error, no more than 5 centimeters. The difficulty, comparable to threading a needle through a moving aircraft carrier during a hurricane. This was the hell-level challenge Chinese engineers faced while building the Hong Kong-Zhuhai-Macau Bridge. John Smith, a member of the American Society of Civil Engineers, once said, achieving millimeter-level precision in deep-sea immersed tube joints. We used to think that was impossible in the real world. Faced with such skepticism, even ridicule from overseas experts, Chinese engineers responded with quiet determination. Yes, the difficulty is unprecedented. Millimeter-level tolerance in these conditions is an enormous challenge, but that's exactly why we must do it. This is our responsibility as Chinese engineers. We will not be intimidated by mockery or doubt, and no technological blockade can stop our progress. We will stay on site, research day and night, and even if we fail thousands of times, we will never give up. And they didn't. Through relentless effort, they invented a technique called composite foundation treatment, injecting special materials into the seabed to turn soft silt into rock-solid support, capable of holding tens of thousands of tons. During testing, engineers worked 72 hours non-stop, failed 137 times, until they finally achieved a 300% increase in load-bearing capacity. On May 2, 2017, during the connection of tunnel segments E29 and E30, a sudden tidal surge knocked them 3 centimeters off alignment. In that critical moment, China's self-developed dynamic hydraulic adjustment system kicked in and within just 15 minutes performed a millimeter-level correction. This move didn't just save the project. It rewrote the rules of sea-crossing tunnel construction worldwide. Today, the 55-kilometer-long Hong Kong-Zhuhai-Macau Bridge is not only the longest sea-crossing bridge in the world, It's a bold symbol of China's engineering prowess. Next, let's talk about water engineering. The Hoover Dam was once a global icon of industrial might, its power output unmatched for decades. But today, China's Baiyatan hydropower station has taken center stage. Its network of underground chambers stretches over 217 kilometers. That's the length of 300 Empire State Buildings stacked end to end. The largest cavern is 438 meters long, 34 meters wide, and 88.7 meters tall, hence can easily accommodate 13 Boeing 737 aircraft. And in terms of output, it generates 3 times the electricity of Hoover Dam. Even more astonishing, while America's Big Dig in Boston went 220% over budget and suffered decades of delays, China built Beijing Daxing International Airport, a massive starfish-shaped megastructure, in just 4 years. It handles 200,000 passengers a day and secured 60 international patents in the process. From cross-sea bridges to hydropower giants, from high-speed rail networks to clean energy megabases, Chinese engineers are pushing boundaries again and again, turning the impossible into reality. They are building, quite literally, the backbone of a nation's rise. These projects show that China doesn't just export infrastructure, it exports a complete development solution. Even the New York Times admitted, Chinese infrastructure is reshaping the global economic order. So how is China defining the next century of human progress? While the US is still fixing highways from the last century, China is already exploring the ultimate future of infrastructure. With each mega project built, China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker of infrastructure maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but also exemplified the strength, spirit, and speed of the nation. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create in the next decade? Please share your thoughts in the comments.